Hi, third grade. Welcome back. How was everything? Let's talk about what you've learned. What did you learn about the Tacoma Narrows Bridge collapse? It was a big deal, wasn't it? Whoops. Get that zoomed in a little bit better. How did you describe it? Some words came to mind when I thought about describing it. It was a massive disaster. It was scary. I also thought, man, I bet that was expensive. Boy, I bet that was expensive to fix. Those are some adjectives I thought of. What were the adjectives you thought of to describe that? Let's turn to page 50. Let's see, 51. 51. So we're going to talk about this page. 51. Problems often happen. If you haven't already, pause this video and get your workbook, page 51. Problems often happen. Even the best engineers can't predict every problem or failure that will happen. They just can't. The best thing to do is to plan ahead to avoid as many problems as you can. I'm going to underline that because that can help you answer back here. How do you think new bridge designs were tested and improved? Well, they probably had to think about as many problems as they could. How could this fail? They had to think about it and say, how could this fail? So if it does fail, we can be prepared for it. Part of being an engineer is learning to accept that things get better after failure. That's kind of like a growth mindset there, knowing that you can learn from your mistakes. That failure is just a normal part of life, even for really bright engineers. I mean, part of being an engineer is expecting those failures and accepting those failures. Finding out what went wrong and why can it help improve this, and why can help improve the design. Meaning you have to find out what went wrong. Part of being an engineer is really digging deep and examining what went wrong and how can I make it better and why did it go wrong, because that can improve the design. You're going to probably have to improve your design multiple times today as you build a paper bridge that is strong enough to hold a few pennies, the most pennies. So sometimes you only need to make small adjustments. Sometimes you need to redesign and test many different things before a design works. So a lot was learned from the Tacoma Narrows Bridge failure. New bridge designs are tested more in wind tunnels. They're tested in wind tunnels. Did you think about that when you made your prediction here, number 1? How do you think? What were your thoughts? How did they design and test new bridges? Well, here's what they actually do. They test new bridge designs in wind tunnels like this, like in this picture here. So how does analyzing failure help you succeed? What did this passage say? The answer is in this passage. Read it again by yourself and answer number 7. How does analyzing failure help you succeed? Analyzing failure helps you succeed knowing your failures help because, you tell me. Let's look at this one. The original Tacoma Narrows Bridge collapsed in 1940. Engineers built a new bridge in the same spot years later. So they did build a new bridge, as you saw in that video as well. Look at each image to see the difference between the original and the current Tacoma Narrows Bridge. So this is the bridge that collapsed. And this is the brand new bridge. What do you notice? What's different? It says, see the difference? This is the original Tacoma Narrows Bridge that collapsed in 1940. There were very little to hold the bridge stiff when the winds blew. The new Tacoma Narrows Bridge has a stiffer, wind-resistant design. Wind-resistant design. Look at this. Look, they have more sturdy structures here that help keep the bridge steady, especially for strong winds. As you have discovered, many different things can happen to a design system or solution that cause it to fail. The Tacoma Narrows Bridge collapse was unfortunate. Ooh, that's a good adjective you could have used, unfortunate. But engineers learned from the bridge failures. Years later, a redesigned bridge was built in the place of the original bridge, one that holds up the wind. Putting it all together, you have to answer number 8. What will engineers do if a bridge design fails during testing? Circle the best answer. Will they just give up on the project? Would they analyze what went wrong and come up with solutions to fix it and then test it again? Or C, would they build a different type of bridge altogether? Or D, try to test it again without analyzing the bridge? Analyzing is another word for studying. What do real engineers do when they come face to face with failures? All right, so you have to make sure for your science lesson today that this is completed. Page 51 and 52 is completed. I hope you were reading along with me so you can find those answers. Also, you need to make sure that number 1 on page 43 was answered. I cannot wait to see your bridge designs. Let's go over that lesson real quick. We're going to go over here to Schoology, and we're going to take a good look at what you have to do. So you have to take a look at your STEAM challenge. You're going to click here and take a look at your STEAM challenge. Can you design and build a single sheet notebook paper bridge that can hold the most pennies? Here are the supplies you need, and here are the rules, okay? You need to read over the rules. Then, once you design, you have a design ready, you need to test your design. Make sure you're testing your design to make sure it works, if it can hold as many pennies as possible. Here are some folding techniques, ways to build and fold. So you might need to cut your bridge some, and you might need to twist it or weave it to make it strong. You decide. It's your bridge, your design. Here are some design ideas. Also, you have here a lab sheet reflection. So you're going to click here, and you might need to blow this up a little bit, but you need to get a piece of paper to answer these questions. You're going to answer, were you successful in the challenge? Why or why not? The number of pennies that your bridge held. What was the most difficult part about the challenge? And what was the best idea you came up with during the challenge? You have to answer those on a piece of paper, and you have to submit a video. Right here it's going to say submissions. You hit upload and then video, and you can make a video reading to the camera your answers. Then, keep going back here. You get to show off your bridge. So this is just a discussion board where you can post a video just showing off your bridge and what you were proud of. I cannot wait to see all your designs. Remember, if you are an in-person student, that means you come to school. You will be doing this lesson in school, so you will not have to do this online. Have fun with this. Bye.